The additional costs for integrating solar cells is not huge. So that means the solar cells pays off for itself.
In this episode, we'll talk about a form of PV that is not really known in the general public yet, and also is not very visible yet because it's just not a common sight yet. But that might change in the coming years. I'm talking about building integrated PV. So just imagine looking at infrastructure or at a building in a city, and for example, you see PV mounted on the rooftop, you see your standard PV panels integrated into the facade, or you actually see nothing. Because one of the technologically as well as aesthetically absolutely exciting aspects of so-called BIPV is that you can either integrate it almost invisibly into, for example, roof tiles. You can also integrate it into facade elements without being really recognizable, or even install it as absolutely see-through transparent glass. So why hasn't it been rolled out on a large scale yet? Could it be one of the important puzzle pieces to make the highly energy-intensive building sector more efficient? And is it already adequately being integrated into legislation such as Fit for 55 here in Europe? Let's find out in this episode. Welcome to the Smartery podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. My guest today has exactly the kind of qualifications you might need to talk about that topic today, because on the one hand, he's been working for engineering and architectural offices all around the world, and at the same time had his focus on exactly renewable energies. At the moment, he's the CEO Europe of ClearVue PV, one of these companies that manufactures exactly what I talked about earlier, a highly efficient see-through glass that has PV already integrated in itself. And he also works on a feasibility study of the UN development program around New Capital Cairo, which is a completely new district that's being built from ground up next to Cairo. So I'm excited to hear his views on BIPV today. Welcome, Dieter Moor.
Yes, hello. Thank you for inviting me.
Let's cut right to the chase. I mean, BIPV does sound amazing, especially in its aesthetically pleasing form, because that would allow you to integrate it into densely populated areas and produce energy right where it's needed. So why are we not seeing so much of it yet?
What I figured out the last 15, 16 years, because I started this business in my previous company, Arctic Solar, a BIPV panel producer from Austria. And what I figured out at that time, there was a huge trend, for example, in Germany about BIPV, because when you consider building integrated photovoltaic needs always a kind of multifunctionality. So if you need only energy production, then the best solution is to put it on a roof or in a green field. But and at that time, when I started this business, that we had no feed-in tariffs, neither in Austria or Germany or all over Europe. And so a lot of companies focused on BIPV. You can see it really on old installations. So let's say 15, 20 years back. But then the so-called feed-in tariff or the Erneuerbare Energiegesetz in Germany came along, and everybody focused on standalone systems or rooftop systems. So at the moment, I feel a kind of reverse trend again. So people are focusing again on envelopes, but it's not a massive volume or a massive business at the moment. And this is always the big question: why is there no more BIPV? Why there are no more BIPV projects out there?
So what I took away from your answer is, on the one hand, that it's a question of legislation. Because in the beginning it was just profitable to mount a PV on your rooftop, and then the legislation changed, so people went for the open field, so to say. And on the other hand, I could imagine, because you said 15 years ago, I would imagine 15 years ago the BIPV was literally your ground-mounted PV just mounted on your rooftop. So let's say it as it is, not a pretty sight. So I guess ever since, we've come a long way also technologically and aesthetically, and it probably looks very different nowadays. So maybe let's focus a little bit on the biggest technological trends here. What has happened since the last 15 years that you mentioned? What's the current status quo? And what would I see if what potential site could I work with as an architect? And what would excite you as an engineer?
Yeah, so there are really two big trends, what I figured out the last years. And one trend, for example, yesterday I had a call with an architect from Germany, and we joked about the situation that, for example, in Switzerland, we both felt that in Switzerland there are more BIPV projects out there compared to Austria and Germany together, because they have less land available. So if they need let's say the turnaround, or if they like to fulfill the turnaround in the energy perspective, they have to go to the buildings. And especially in Switzerland, there came a huge trend in the so-called colored BIPV, because some of the legislation or the municipalities, they say, we don't want to see this black and dark and shiny PV panels in the facade systems. And so some of the architects and developers realized that we have to go in this direction and make some nice looking PV panels. And when you see the timeline in terms of efficiency of the PV panels, we can say the efficiency increased year by year. And what we are doing now is we are putting some colors in front of the solar cells or in front of the glass, and we are coming back to levels, let's say 5-6 years ago. So that means we are reducing the power output, but with the additional option that we have wonderful panels in the facade system. And as similar, and this is the second trend which I figured out, is that one with transparent or semi-transparent solutions. If you imagine a lot of buildings are built with clear glass, this is was one big trend in the last years, to make transparent buildings, open buildings, especially banks. They're standing for their transparency. But it often has problems with thermal impact on the building, cooling demand, and things like this. And in this area, this is what I'm representing now with ClearVue PV. We have really a possibility to make transparent windows which harvest the energy on the edge of the PV window, and have also this kind of multifunctional approach for a PV panel.
So just to break it down on a non-expert level here, the first that you mentioned would be your standard PV, like a black looking PV that's highly efficient nowadays, but you would cover it with a little bit of cover, take a little bit away from the efficiency, but give it a new look that could be better integrated into a facade, for example. And the other version is something that literally looks like my window in my average apartment.
Yes, these are the two trends too. Yeah, this is ongoing.
How do they compare in terms of efficiency and also in terms of pricing?
In terms of efficiency, when we speak about installed powered, because this is one of the key figures when you speak with the electricians or with building owners. When you take a standardized panel, so from the mass market, so we speak about sometimes 200 watt on a square meter, what you can install. So the best panels at the moment. With colored solutions, you come down. Sometimes it's related also to the different glass thickness, because when you go into buildings, you need thicker glass concerning the wind loads and things like this. Then you come down to 150, 160 watt per square meter. And for real transparent solutions, and when I say real transparent, then I mean really there is no, let's say, no stripe or no cell or anything in the window, we come down to 30 watt per square meter. So to be honest, you can't directly compare it, because the one is the PV panel with, let's say, maybe a cladding function, but you can't see through. And the other one is really a window where you can see through and can replace existing insulated glass.
You can't compare it in terms of efficiency, but of course, I mean, the option is very comparable. The option of like your traditional PV can only be on the roof, whereas if you have a huge glass facade in an office building, you suddenly have PV and energy production where you did not have before. So you basically are a from zero to a lot better. So.
To be honest, ClearVue invested a lot in different, they called it archetypes building, and they simulated a project, for example, in Toronto, and said, okay, we have 90% of the south facade is glazed with ClearVue glass, 70% of the east and west facade is glazed, and 40% of the north facade. And in this, let's say, archetype, or in this simulation, they figured out that you can come down to a zero emission energy building, or zero emission building, but related to also installation on the roof and on some panels on car parks. But that means, on one hand, you need to reduce your energy consumption in terms of heating and cooling, and supply the rest of the energy with using the whole envelope of the building.
Nevertheless, what it really does is it opens new doors to absolutely new applications, because I think if you just think of your traditional black PV, people just would not want to have that on the aesthetically important areas of their house. It's a little bit like wind turbines, it's nice to have them as long as they're 2 kilometers out in the countryside and do not block my view. So I guess that really tackles a big problem when it comes to public opinion and opens up a completely new door. Now, we haven't covered the cost aspect. We'll come back to it, because apart from, of course, the energy consumption, if you talk about BIPV in a city infrastructure, it on the one hand replaces windows, which you do not have to buy anymore. So there's like an additional cost benefit, I would assume. And on the other hand, it probably has to cater to a lot more different needs that you probably could combine even smartly. So what kind of synergies open up if you talk about a smart city environment?
Yeah, ClearVue, for example, is going also in this direction in terms of smart building products. So they don't consider only the energy production from the window. So they are going one step further and say, okay, that energy which is produced in this glazing could be directly used for additional functionalities. For example, moving blinds, or nowadays, with COVID, we need all fresh air in the room. So you can make a CO2 measurement inside the building, and the window itself, so to say, starts to exchange the air in the room. Or also a new trend at the moment is things with switchable glass. So you can connect the PV panel or the PV window with the switchable glass and can reduce also your energy consumption. If you imagine you darken your window during a hot summer day, you have less energy impact into the building. Yeah, so this is also, let's say, one step further into smart products.
I guess it also solves another problem. If you use the energy directly in the facade, you do not have to deal with feed-in tariffs or anything like that. You just have your little internal smart grid.
Yes, that's right. Yeah.
So we talked a lot about BIPV in the terms of, for example, windows or facade elements. But what other areas or surfaces in an inner city environment are interesting for BIPV?
Yeah, basically we can say everywhere where we install glass, we can install also BIPV. And as I mentioned before, in some federal states in Germany, for example, the PV obligation is related to car parks. So if you build a building where you have, I don't know which federal state it is, but if you have more than 30 car parks, you have to install a carport with active solar panels. So this, from my perspective, these are also really huge areas which we can use. A little bit smaller areas are art objects, like walkable sun monuments and things like this. At my previous company, we did a couple of things, because this is a good eye opener, let's say, also to all of the visitors, because then you can build PV panels also in other ways, not only rectangular 1 by 2 meter. And so it's for education, let's say.
So I can understand, like, in terms of creating public awareness, that's absolutely ideal. In terms of scalability, obviously that would not that would not be that the highest contribution. So what kind of infrastructure elements really could have a a big impact? Sometimes you hear about bike paths or freeway roofing. Which of these do you think are really feasible?
I know that there's also a research project ongoing between Austria, Germany, and Switzerland, also to clad all the motorways with PV panels. But as very similar to the normal building integrated solutions, there are a lot of open questions in terms of fire rating, safety measures. If you go really in a horizontal glazing about a motorway, you need to have reliable products which are stable enough to hold wind loads, the suction and pressure from the cars and so on. But from the potential, I think it's amazing to go in these areas. But all the others, normally also, for example, railway stations are very attractive for BIPV, because then there is also the combination between the trains using the electricity. So it's obvious that we use the cladding material, which should produce electricity for the trains itself. There are some initiatives ongoing, yes.
So when I do listen to you, Dieter, it sounds like technologically we're in a good position at the moment. There's enough showcases, there's enough pilot projects for all various use cases. May it be integrating BIPV into an office facade, may it be integrating it into a parking lot. There's even interesting use cases that are being researched, such as the bike paths we talked about. So why hasn't it moved away yet from the pilot stage and really into mass adoption and countless projects out there?
I think that we should distinguish a bit between, let's say, mass products, so mass market products, which are, for example, shingles for private roofs and so on, and lighthouse projects, so these really high-class projects with star architects. And there is also room in between. But when I realized project in the past years, I always asked myself why one project was realized and the other one not. And the answer was always that we need three key players in this game. We need an investor or the building owner who is willing and able to pay for it. And it doesn't matter if it's an apartment building or if it's a municipality center, whatever. So they need to be convinced that it's a good thing. And the second one is the architect who is willing and able to create with this material. And the third part is the industry who is able to provide that was engineered. And if only one of these three is not convinced that it's a good thing, then you can forget every project. For example, if the investor says it's too expensive, the architect can plan everything. Nobody will pay for it. So this is my conclusion out of the last 20 years, let's say, that it's not always the price question or the cost question, let's say. But if we go on the mass market, I'm convinced that panels should be, let's say, cheaper. And this is always this chicken egg problem. So they are getting only cheaper if we have a mass market, but if there is no mass market, it's one of the bigger problems at the moment.
So that to me sounds like all levers are in place, but it still needs some wiggling until all the different stakeholders really come together. So I think that bears two questions in terms of, I guess one of the most important one is investors having a price efficient product. So how price efficient is it? And the other question would be, then legislation might change very quickly. I assume in Germany there's a lot of talk about making it mandatory to plan new buildings with BIPV. So are those the two most important developments we'll see?
Yes, the most important, and yes, followed by, good services, engineering and things like this, because this is at the moment also luck, let's say, because a lot of projects are, not well engineered, and you start to supply panels during the installation or during the production. And because there is at the moment no huge tradition and culture in terms of BIPV design. So this is something from my perspective which needs to be established also in the coming years to avoid problems.
I'll come back to that in a minute, but just quickly to get a very concrete answer, like how price efficient is it? Because to me it sounds like something, to a non-expert, it sounds very fancy and expensive to have, for example, have a glass facade in an office building. Or is it something that is price efficient because, for example, you do not need to get the traditional glass facade?
It's also not one answer, but what I can make an example. For example, we did in the past a lot of handrails. And when you consider you make a handrail out of glass, it's very expensive because glass is, when it's getting thick and when you use low iron glass, it's very expensive and architectural pleasant and so on. And then the additional costs for integrating solar cells is not huge. So that means the solar cells and part of the glazing and installation pays off for itself, which the normal glass will never do. This is one example, for example, handrails. If I go in an insulated glass unit, I have to calculate a little bit more in terms of what are the benefits. It's not only the benefit about the energy production, it's also the reduction of energy consumption, because with the solar cells, I reduce my thermal impact into the building. And this is also something which needs to be counted. And it's always related to the certain region, to the energy price in the certain regions, to the consumer. Is it an end consumer or a municipality with different energy prices? And then you can also calculate kind of payback time or kind of efficiency on the economical perspective.
That to me sounds like it really does take a lot more dedication, because that means as an engineer architectural office, you really need to have some long-term calculations about the cost benefits, because it's not just your costs for installing it and then your average lifetime, but it's really about how does it affect your energy bill, how does it affect insulation, etc., etc. What other things are important to consider when talking about planning and implementation?
I always say BIPV is not rocket science, but nevertheless, you should consider that it's on one hand glass and facade engineering, and on the other hand, you need to integrate the PV and the electric know-how. And at the moment, there are only few engineering offices in Europe who are able to combine these two worlds. But if you don't do it, you can have a lot of problems in terms of losing some information, or, for example, the electricians rely on what the facade industry is doing and other way around. So this is very important. What we all know from other disciplines, for example, if we design a building, we know we need a guy who's calculate the structural loads and things like this. So everybody pays for that this is properly dimensioned. But in the BIPV business, it's on a very early stage, but needs to be also considered that on the long-term run, we need people who are experienced in these disciplines.
And last but not least, when it comes to PV, most of it is produced in Asia, namely China. Is that the same for BIPV?
This is a very, very good question, because I think BIPV is more a local business, because when you have a flat roof or a inclined roof, a pitch roof, you can install panels 1 by 2 meter, and so it's really not rocket science. But if you say there is a building and an architect likes to have a design for the facade, he can't work with companies overseas, because the time zones and sometimes also the language barriers and so on. So from my perspective, the engineering needs to be done more or less on site with the architects, with the facade industry, and also the production, because it's impossible to ship all these goods from China. Also in terms of production time and shipping time, and at the moment with COVID, container prices are going up. So it's really worth to establish BIPV industry here in Europe. And there are some initiatives are also ongoing in Brussels to combine and strengthen the BIPV industry here.
All right. So that sounds like, on the one hand, it will create some very highly educated jobs, because it's a big task for architects and engineers to really make it happen. On the other hand, we know that legislators will push for it. So it's a market that will grow, and anybody who gets a foot in now already will be positioned perfectly for the years to come. Plus, it's something that really only works out if the whole value chain is locally, which of course would be good news for local industries and the local employment. We're already at the end of our episode here, so thanks for having joined us, Dieter. Let me just quickly think what my biggest takeaways are. I think BIPV is quite a diverse field. You have your standard solar panels just on the roof, mounted just as rooftop mounted PV. You have your colored solar panels that then can be integrated into aesthetically important parts of the building, and you have your absolutely clear see-through glass that could be a part of a window or just your normal office facade, for example. And of course you have all the use cases that you mentioned, like carports, bike lanes, maybe even above car lanes. So it's quite a diverse field, a field that still needs to be developed in all its aspects, may it be economically, may it be in mass production and mass application. But I think we will see a lot of development there, because as governments all around the world focus on the building sector as a whole, they will also zero in on BIPV, which means we'll see a lot of development in the years to come in regards to the economic development and production scales. So I hope in a future episode then we'll be able to talk actual growth rates and market predictions. And I'm very much looking forward to that, but we'll have to make it happen first. So thanks a lot for an insight into the status quo of BIPV today. Thanks a lot, Dieter.
Thank you also. It was a pleasure.
More innovative solutions in the field of PV can be found at Intersolar Europe, the world's leading exhibition for the solar industry, taking place in Munich. Since its inception more than 30 years ago already, Intersolar Europe has established itself as the most important industry platform for the solar industry among manufacturers, suppliers, wholesalers and service providers. All information about the exhibition and conference can be found online at intersolar.de.